Hi, welcome to Unit 6, Day 1, Intro to Moles. So in the previous unit, we learned about chemical reactions. And here we have a chemical reaction equation that is balanced. And this chemical reaction is a double displacement, specifically a precipitate reaction. Now I'm going to color code it just because it's easier for us to see that this is a double displacement. Now when we're looking at a reaction equation like this, what we're seeing by the coefficients, which tell us the number of each molecule that we have, is that in this reaction, 1 lead nitrate and 2 potassium iodides go to produce 1 lead iodide and 2 potassium nitrates. So as you can see here, a balanced chemical equation sort of sounds like a recipe, right? So let's compare a recipe for, let's say, chocolate chip cookies with that same balanced chemical equation. The ingredients in the recipe and the reactants in the chemical reaction equation are sort of the same thing. Like the reactants are like your ingredients, is what you're starting with. And the products are sort of like the food that you make. And remember, these coefficients are sort of like the measurements in the reaction and the recipe that tell you the amounts of things that you have. So where the chef will use a recipe to know how much of each ingredient to measure out and determine how much food can be made, a chemist will use the balanced chemical equation to know how much of each reactant to measure out and how much products can be made. Now, if we think about this chemical equation as we see here, and we interpret it this way as saying that there's 1 lead nitrate and 2 potassium iodides that can make 1 lead iodide and 2 potassium nitrates, well, you may be asking yourself, can a scientist really measure out 1 lead nitrate and 2 potassium iodides? Molecules are really super small, right? So a scientist really can't measure out 1 molecule and 2 molecules very easily, right? So because a scientist can't measure small numbers of molecules out, what they use instead is something called a mole. And when I say a mole, I don't mean a small fuzzy animal that runs around underground. I'm talking about a unit of measure. So a mole is sort of like a dozen. It represents a number of things. Like 1 dozen is equal to 12 things. Well, 1 mole is equal to 6.02 times 10 to the 23 things. And this number is such an important number, it actually has a name. It's called Avogadro's number, and it's named after an Italian scientist. Now, 6.02 times 10 to the 23, that's a huge number. Let me show you how huge it is. After the 2, there are 21 zeros. And that number represents 602 hexillion. Like I said, that's a huge number. And the reason why it's such a huge number is because atoms and molecules are really super tiny. So in order for you to have any amount of it, you're going to need a lot of atoms and molecules, any significant amount for you to measure. All right, so let's dive into this a little bit further. All major amounts can be expressed in moles, and that's why moles is the central unit of measuring for it when it comes to amounts. So moles can be used to represent volume of a gas at standard temperature and pressure. It can also be used to represent the number of atoms or molecules, so if you count them. And it can also be used to represent the mass. Now, because moles is a central unit of measure, you can convert from one amount to another by going through moles. And in fact, you have to. So for example, if you have the volume of a gas at standard temperature and pressure, and you want to know how much that gas weighs, you would have to convert from volume to moles and then from moles to mass. Now, this image that you see here is an important tool. It's known as the mole map, and it shows the central unit of measure for amounts. And we use this tool when we are doing our mole conversions, which we'll be doing in this unit. So let's go back to our balanced chemical equation, which is where we started. Remember, we said that we can read this as 1 lead nitrate and 2 potassium iodides make 1 lead iodide and 2 potassium nitrates, correct? And we also said that a scientist can't measure out 1 or 2 molecules at a time. So instead of thinking of the coefficients in terms of counting numbers, we can also think of them as representing moles, because moles is representing an amount. So that works perfectly. So the coefficient represents the moles of reactants and products, and they're often called molar coefficients for that purpose. So instead, we can think of this as saying 1 mole of lead nitrate and 2 moles of potassium iodide make 1 mole of lead iodide and 2 moles of potassium nitrate. So these coefficients represent the moles that you need for each reactant and the moles of product you can make. So let's do a quick summary of what we learned so far. Moles are very important in chemistry, and they're important because they're the central unit of measure for amounts. And a mole is like a dozen. So where 1 dozen represents 12 things, a mole represents 602 hexillion things. And again, that number is important. It's known as Avogadro's number. Now, the coefficients in the balanced chemical equation represent molar coefficients. So in this unit, what we're going to learn about is the definition of a mole and understanding its importance in chemistry, which we kind of already started that. We're also going to practice calculations involving moles using the mole map. And we're going to do 1-step and 2-step mole conversions. Finally, it's important to know that the skills that we learn in this unit are going to be super helpful for us in the next unit known as stoichiometry. Now, in the next class, what we're going to begin to do is we're going to begin to explore moles, mass to moles, and mole to mass conversions. And we're going to calculate, in order to do that, we need to learn how to calculate what's known as the molar mass from the chemical formula. And we're going to use, as I said, we're going to use that molar mass for those conversions. So essentially, we're going to be focusing on this section of the mole map. All right, so that is it for the Unit 6, Day 1 intro video. Have a quality day.